Okay, so this is topic 1.11, part 2, and this is Pascal's triangle and the binomial theorem. There's a lot of stuff on here. I'm going to try and explain it in a basic method. For those of you who have never seen Pascal's triangle, it's actually pretty cool, and it's made basically by using ones, okay? What it basically does is help us multiply out binomials when we are doing them to a ridiculous power. Okay, so if I asked you to do x plus 3 squared, right, that would be x plus 3 times x plus 3, and you would get x squared plus 3x plus 3x plus 9, which you would then hopefully simplify to x squared plus 6x plus 9, right? If I wanted to do it to the third power, I would have to multiply the first two. That's your x plus 3 squared that we just did, and then you would have to distribute it out again. Okay, and again, at this point, you'd now be multiplying 5 times. Not a big deal, little tedious, but not a big deal. So x cubed plus 6x squared plus 9x. Again, we're just distributing. 3x squared, 18x, and 27. And then you would basically add your like terms. So I have an x cubed, I have 6 and 3x squared, I have 9x and 18, and then I have 27. Okay, there is a shorter way to do this. You can ignore a lot of this, the binomial theorems, because it's not something that you're going to actually have to do. You're not going to have to do the statistics stuff that comes from it either, unless you take AP Stats next year, just saying. And then when you do, I'll teach you the formula by hand, and then we use the calculator for it because that's what it's for. Okay, so again, you can ignore most of this. Okay, so basically, if I want to raise it to a specific degree, okay, this is what the Pascal's triangle looks like, and it will go on infinitely. But I need you to understand it is made by starting with 1, okay? So the first row, that row 0 is always 1, and then see how the 1s trail along the outside, okay? The rest of these are literally made by adding the 2 numbers that are above them. Okay, so you were literally creating this out of nothing but ones. Okay, and if you can basically add and just keep going with ones, again, this thing could go indefinitely. Okay, if I wanted to add the next row, obviously I would start with a 1 on the outside, both sides, right? And then I would start adding the numbers above it. So 1 plus 7 is 8, 7 and 21 is 28. 21 and 35 is 56, 35 and 35 is 70, 30, and then it's symmetric, so it goes back out the other way. And I could keep adding row after row after row. So what you need to understand is that the row number is your degree, right? So if I told you to do, let's do that x plus 3 again, x plus 3 to the third power, you would need the row that has the 3 in it. That would be the third row. So it's this 0 row, that would be the 0 degree, first degree, second degree, third degree, that 1, 3, 3, 1, okay? This is how this works. These are your coefficients, your coefficients when you start multiplying, okay? This is your first term, we'll call that A, and 3 is your second term, right? This is a binomial, 2 pieces. A is x, and B is 3, okay? I need to do 1, that's the first term, times my A value to the third power, okay, times my B value to the 0, because 3 plus 0 is 3, and these have to be, each of these pairs has to add up to that degree. The next one, 3 for my coefficient. You'll go down on the A's and up on the B's. So the next one will be A squared B to the first, right? This 2 plus 1 still adds up to 3. Again, next coefficient, 3 times A to the first times B squared. And the last one is 1. Let me move this over. Again, it's just about multiplying it out and knowing which pieces are what. Oh, move, you silly thing. There we go. Okay, so I actually have some more room. Okay, so the last one would be 1 A to the 0, B to the third. And again, each pair always adds up to the degree that you're on, and the degree you're on tells you your row. If I plug in what I have for my A and B terms into this, what I'm going to get, okay, is 1, okay, well, a is x, so that's just x cubed. Now, if you remember your exponent rules, anything to the 0 power is 1, so that's gone. All right, the next one would be 3 times, well, that's x squared times 3. That's my b values, times 3. So that would be 6x squared. So 1x cubed plus 6x squared. Okay, we did do x plus 3 on that one, didn't we? Why is it not coming out as 9? Oh, wait, hang on. Hopefully I'm not having a moment. Was x plus 3? Yeah, it was x plus 3. So 1x cubed, and it should be 3 times x squared times... Oh, I'm having a brain fart. 3 times 3 is not 6. 3 times 3 is 9. Try again. Oh boy, tired. All right, go to the next one, and that's going to be 3a 1x, right? And then b squared. So 3 squared is 9. 3x times 9 is 27x. And the last one is 1 times no x's, a to the 0 is gone, and then whatever b is cubed. Well, 3 cubed is 27. And that's how that works. Again, it's not such a big deal if you're doing squared or cubed, but what if you want something to the 7th power, right? Or what if you only want to know one piece of something that's to the 7th power? You could actually just do the individual term as long as you know what your degrees are going to be, right? And it's always the first one starts off with the highest degree possible and then counts down. And the second one starts off at 0 and counts up. So let's do a couple practice ones of these to see if you can get it. No, you don't need to know that. Okay, so let's do x plus 2 to the 5th power. Okay, so the first thing I need if I'm going to do x to the 5th power is I need to know what the 5th row of Pascal's triangle is. Okay, so remember that's row 0, row 1, row 2. We're adding, remember, that's row 3. That's row 4. And again, I'm just putting the ones on the outside and adding. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. There's my 5th row. Okay, so that's my 5th row. I'm going to have 1, 2, 3, 4, 5, 6 terms. Okay, so I'm going to have 1 and 5 and 10 and 10 and 5 and 1. Okay, my first term, whatever your A is. My second term is whatever your B is. Okay, and like I said, first term starts at the highest degree and works its way down. So that would be x to the 5th, x to the 4th, x to the 3rd, x squared, an x, and then an x to the 0, remember, doesn't mean anything. It's just gone. Okay, now go to the next term. That would be 2 to the 0 here, which we don't keep. 2 to the 1st, 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th. And then I just need to simplify it. 1x to the 5th does nothing. Okay, 5 times x to the 4th times 2, which would be 10x to the 4th. Okay, 10 times x cubed, well, 2 squared is 4. 4 times 10 is 40, x cubed. Okay, 10x squared, and 2 cubed is 8, right? So that would be 80, x squared. 2 to the 4th is 16. 16 times 5 is also 80, so that's 80x. And then 2 to the 5th is 2, 4, 8, 16, 32. And I'm done. And it's much faster than trying to multiply it out once you get into it. And again, I'll show you on the last example, if I only want one specific term, I can actually do it from this because I only have to multiply that one piece out to get it. Okay, so let's try this one. We're going to the 4th, so I need my 4th row, right? Row 4, not row 0. Don't think of this as the top row as row 1. Remember, it's row 0 because anything to the 0 power is 1. All right, so A is 2x and B is -1 this time. So we're going to have to watch when our signs change because you're going to be multiplying -1 repeatedly. Okay, so again, write out my coefficients. 1, 4, 6, 4, 1. Okay, so I'm going to have 2x to the 4th, 2x to the 3rd, 2x to the 2nd, I'm going to run out of room, 2x to the 1st, move that 1 down a little bit, okay, and then 2x to the none doesn't need to be there. So now your B term, so not anything here because that would be -1 to the 0. So this is going to be -1 to the 1st, -1 squared, negative 1 to the third, negative 1 to the fourth. And now I just need to simplify. Okay, so remember that if I am raising something to a power, it applies to everything in the parentheses, right? So 2x to the fourth is 2 to the fourth and x to the fourth. So that is 2, 4, 8, 16, 16x to the fourth. Okay, 2x cubed, well, that's 8x cubed. 8 times 4 is 32 times negative 1. So negative 32x cubed. I'm doing this in pieces. Okay, so you can write it, if you need to, you can write the next step down below if it makes it easier for you, especially if you're getting into one pieces like this. So this is 1 times 16x to the fourth. This is 4 times 8x cubed times negative 1, right? That's going to be negative 32x cubed, if it makes it easier for you to see it. Okay, so this is going to be 6. Well, 2x squared would be 4x squared, right? And negative 1 squared is just positive 1, because it does cancel. So 6 times 4, that's 24x squared. Next one, the 4 times the 2x doesn't change. Negative 1 cubed is back to negative 1. So that's going to be negative 8x. And then negative 1 to the fourth power is just plus 1. Again, way faster than actually multiplying it out by doing all the double distributing. Okay, and like I said, on the other ones, I can actually go ahead and just pull out the term that I want. Okay, so I'm going to the 6th power now, so that means I need row 6. So it's going to be 1, 6, again, adding what's above it, 15, 20, 15, 6, 1. Okay, so I want the 6th one, so I can write them out if you need to see it. 1, 6, 15. I am not going to multiply this whole thing out. 20, 15, 6, 1, because all I care about is the one that has x to the fourth. Well, we know that's going to be x to the 6th, x to the 5th, x to the 4th. So I only care about this term, right? If this is x to the 6th, then this would be 5 to the 0, right? This would be 5 to the 1st, and this will be 5 squared. This is the only thing I care about that I have to multiply because it's got the x fourth term. So this is 15 times x to the fourth times 25. Well, 15 times 25, that's 250, and 125, that's 375 x to the fourth. And I'm done. I only need that term. Okay, we'll try another one. Oh, I need the 8th row. Oh boy, I'm gonna have to keep going now. All right, get this out of the way. All right, so expand this further. And again, it's just adding 1, 7, 21, 35, 35. And it is, again, symmetric all the way down. All right, so then 1, 8, 28, 56, 70, 56, 28, 8, 1. Okay, so this is my 8th row. I want just the x cubed. Okay, so this one's going to take a little bit longer to actually get all the way down to. So let's see. This one is going to be x to the 8th, right? 8 is going to be x to the 7th. 28 is going to be x to the 6th. 56 is going to be x to the 5th. And you could count across x to the 8th, 7th, 6th, 5, 4. We know the 3 is going to be over here. Plus 70x to the 4th, plus, there it is, 56x to the 3rd. So I only care about this one. All right, so remember that the exponents have to add up to 8, right? The two exponents between them when we were multiplying them out, this one always added up to 4. Well, if the x is to the 3rd, then that 3 has to be to the 5th power. Okay, so 3 to the 5th. Oh, Lord. 3, 9, 27, 81. 81 times 3 is 243. So 56 times x cubed times 243. Oh, brain's going to fry. I'm actually going to have to work it out. So 243 times 56. 18, carry the 1. That's 25, carry the 2, 14. Let's see, 15, carry the 1 is 21, carry the 2, 12. 8, whoo boy, this is big. 10, carry the 1, 6, 3, 1. So literally 1, 3, 6, 0, 8, x to the 3rd. Could you imagine having to multiply that out the whole thing? Much, much easier. Again, just takes a little bit of practice. And that is it for part 2.